Welcome. So in this video, we're going to begin talking about types of transformations. Now, before we dive into the notes, I just want to zoom out for a second and just appreciate where we've been so far because it's going to be important. So you don't have to write this down. So far, we've been talking about linear associations. So as you can see here, we have a data point between male life expectancy and female life expectancy. And when we plot all these data points, we can put in a regression line through this. And the reason why we can do that is because we have a linear relationship. It looks like that. It looks like a straight line through it. What we're now going to see is non-linear relationships. So as you can see, these have curve to them, a curve like that. Now, when we're dealing with non-linear relationships, we can't apply all the analysis that we did to linear relationships. So what we want to do is somehow take these non-linear relationships and change them or transform them so they become linear relationships. And that's what we're going to be learning about. So we're going to learn about how to transform some relationships here. Okay, let's read through these notes now to get a better understanding of what I'm talking about. So it says, even if you have a high R value, a residual analysis may show you have a non-linear data. We can transform one of the variables, to make the relationship more linear and the least square regression equation more reliable. The appropriate transformation can either stretch or compress the scale of one of the variables. The three forms of transformation we will concentrate are squared transformations, log transformations, and reciprocal transformations. In most cases, there are a number of suitable transformations that could be applied to make the data appear more linear, and therefore more suitable for applying a linear regression analysis. Using the information given in this chapter and the summary chart below, which we'll be looking at, you should be able to identify which 1 to 3 transformations would be suitable. It is then a case of testing each transformation to obtain the best model for the given data. And then we've got a note here that says these transformations only work on strictly increasing or decreasing functions. So what that means, if we can picture something like this, if I draw myself some axes, if we had a relationship that looked like this, so maybe it goes up and up and up, and then it kind of goes down and down and down. Do you see how this is going both up and down? If this is happening in which we have an increasing and decreasing, you can't apply any transformations to this. You can only transform something that is either increasing or decreasing, not both. Okay, now we come to this summary chart here. Now, this is very important. This is going to be in your bound reference, and it's something that you really need to be comfortable with. So it's called the circle of transformations. And as you can see here, we have some possible transformations, and these transformations are going to make our graphs more linear. But you have to see which is the most appropriate transformation. So for instance, let's say that your graph looks like this. So it's got this bend to it here. That means you would use y squared, or maybe log to the x, or maybe 1 on x. If it looks like this, so it's got this curve to it, you'd use either of these transformations. If it looks like this, you would use one of these transformations. Look, there's 4 there. Or if your graph looks something like this, you would use one of these transformations. So it's important that you know where to refer to so you can determine what type of transformation you should be applying to based on what your graph looks like. So it's important that you know where this is in your bound reference and you know how to use it. We've also got this down here. It says, once you have identified the best option and applied the transformation, you must check and compare the scatter plot, residual plot, and R value for each of the transformed data sets. Perfect. We're going to stop here and we're going to go through some examples together, and we're going to see how all of this works.